Hi, in this video we're going to review motion in two dimensions, starting with vectors, also including projectiles. Remember first of all that a vector is some quantity which includes both a magnitude, which is a fancy word for size, and a direction, like up, down, north, east, south, or west. Examples of vectors include displacement, velocity, acceleration, and force. Numbers that aren't vectors are called scalars. Those are things that don't include a direction. Remember, when we represent vectors graphically, we draw an arrow to represent them. The size of the arrow represents how big or the size or magnitude of the vector. And the direction, of course, is indicated by the direction the arrow is pointing. Algebraically, with a symbol, we would represent a vector with an arrow above the symbol like that. It should only have one arrowhead on the top. When we add vectors, remember that we always draw them tip to tail. Where one vector ends, the second one begins. So for instance, if we're going to add those two vectors, we need to draw them so that they are tip to tail like that. Remember that the order doesn't matter. You can add them in any order. The resultant starts where the first one begins. Maybe you call that the origin, and ends where the second one ends. So in my example, the resultant will look something like that. We can use Pythagorean's theorem to figure out the magnitude of the resultant, since we'll know both the sides of that right triangle. And we can use the tangent to find an angle to indicate the direction of our resultant vector. Remember that when we multiply a vector by a scalar, we simply multiply the magnitudes. And when we multiply a vector by a negative scalar, we simply reverse the direction. So let's look at an example from your review. This is question 5b, where we have three vectors and we're being asked to subtract L minus M. So L is told to be 6 meters to the north, M is 6 meters to the east, and so first we would draw them tip to tail. So L would go up, minus M would go to the left. So remember, minus M is kind of like net multiplying by a negative, we reverse the direction. The resultant will look like that. So I can do Pythagorean's theorem to figure out the resultant, which is about 8.5 meters. That would be the magnitude or the size of that resultant. Use that angle right there, find its value, and so you could do that using the tangent. And so the inverse tangent of 6 over 6 would be 45 degrees. If you can recognize that both sides of the triangle are the same and call that 45 degrees, great. The way that you would write that is to say that R is 8.5 meters, 45 degrees north of east, or something to that effect. When we resolve vectors, that means that we break them up into two perpendicular components. Call them x and y components because we choose them to always be parallel to an axis. So if we have a vector that looks like this, the x component will look like that. The y component will look like that. We can use sine and cosine to find the sizes of those two components. We have the adjacent side, in this example that's x, the opposite is y, and the hypotenuse is always a given. Remember, we always going to draw a diagram first, not just simply try to remember that x is always this trig function or that y is always this trig function. Draw a diagram first and then decide which function goes with which component. So let's look at an example from your review, question 3a, where we have a projectile being launched 40 meters per second at a 30-degree angle, and the first thing we're going to do is resolve it into components. Even if you're not told to do this, if you have an angle, you need to resolve it into components to get rid of the angle. So I'm going to use the cosine to find Vx. And so the cosine of 30 degrees is adjacent over hypotenuse. And so Vx would be 40 meters per second times cosine of 30 degrees, which would be 34.64 meters per second. We're going to do the same thing to find Vy, except we're going to use the sine function. So the sine of 30 degrees would be the initial velocity in the y direction over 40 meters per second. And solving for V initial in the y direction will be 20 meters per second, and we should indicate that that is up. The other 2D motion big concept we had was that of a projectile. Remember that a projectile is something that's in free fall and moving forward. Like it's not just tossed or dropped, it's also projected forward. That means that it's moving in two directions, the horizontal or x direction, the vertical or y direction. Remember that in the x direction the velocity is constant. There's nothing making it accelerate. In the vertical direction, remember that we're accelerating due to gravity. Remember that gravity is always directed downward. There's lots of trick questions about the direction of the acceleration. Remember that it's always directed downward. If we plot the position time graph in both directions, it will look something like that. X direction, constant velocity, so it's a straight line. Y direction, it's a parabola. If we graph the velocity versus time, it will look something like that. If we kind of draw out a motion diagram for a projectile that's launched at some angle, of course we would resolve it into components first, because those are the things that we know information about. Projectile would follow a parabolic path like that. As it goes up, the distances between them would get smaller. As it goes down, they would get bigger. Horizontally, they should all be the same distance apart. You move forward with constant velocity. So Vx is always the same, points forward, doesn't change in size. Going up, your projectile is going to slow down until it stops at the top. So it's an important thing to remember that the vertical velocity is 0 at the top. Coming back down, it speeds up again. So those velocity arrows should get longer as it comes back down, because gravity is making it speed up as it's coming back down. So again, remember that the acceleration is downward due to gravity. Don't be fooled by any sort of trick questions about reversing the direction of the acceleration. It's always down. Another important thing to remember about the velocity is that the velocity right before we hit the ground is the negative of the initial velocity. So if we've got a v initial y that's 20 meters per second, right before we hit the ground, the velocity is negative 20 meters per second. It's also important to remember that at its maximum height, the vertical velocity is 0. The special case of a horizontally launched projectile, which is where we started with projectile motion, remember that the initial velocity is going to be all in the x direction. Horizontally launched means that the initial vertical velocity is 0, and so whatever velocity we're given is the Vx. Make your initial position in the y direction 0, and then you can make your acceleration positive. Remember, it's positive g. And then remember that the two directions of motion are independent of each other. The only thing that links them together is the time. So let's look at another example. This is from your review. This is question number 2. We've got some projectile launched horizontally. It lands 42 meters away, and it takes 2 seconds to reach the ground. And so the first thing that we should do is create a table for our givens and unknowns, an x and a y. Here's all the things that we should be looking for. And of course, time is the thing that links them together. So filling in my knowns on the y side, make my initial position 0. Y is unknown. Your initial velocity is 0. That needs to come from your head. And your acceleration is 10 meters per second squared. That also needs to come from your head. Time is 2 seconds, that's a given. X is 42 meters, and Vx is a question mark, that's an unknown. We're being asked to figure out both Vx and y. So finding the height first, our equation of motion, y equals y subscript 0, plus initial velocity in the y direction times time, plus 1/2 at squared. I can take out those two terms because they're 0, and then I don't have to do any solving. I can plug right in, and we would get y as 20 meters. Solving for the velocity, we have to remember that that velocity is in the x direction. So it says find the initial velocity, that means find Vx. Since the x velocity is constant, we can use our constant velocity equations of motion, like v equals delta x over delta t, and then simply divide, we get 21 meters per second for that. For a projectile launched at an angle, remember we have one step that we have to do before we start solving the problem. Always need to resolve the initial velocity into its x and y components first. We can't do anything with that angle, but we can do everything we need to with just the x and y components. Remember, the vertical acceleration is going to be negative g, negative 10 meters per second squared, because your velocity and your acceleration are going to be in opposite directions. One of them has to have a negative sign, and so it's easiest if we make g negative. If we're going to land at the same height that it's launched from, remember that the final velocity in the y direction is the negative of the initial velocity, and both our y and our y initial are 0. Also remember that at maximum height the vertical velocity is 0. So those are all things that need to come from your brain. So let's look at an example. From our review, question number 3, which we already started back in our vector review, we did the first step of resolving the velocity into its initial y component and its x component. Remember, even if you're not told to do this, that needs to be your first step. Part B, we're asked to find how long it's going to take the projectile to return to the ground. So setting up our table, those are all of our givens. Before we can figure out what the x is, we have to find the time first. Since I've got a question mark on the x side, I'm going to use the y side to find my time. Now this will be a lot easier if we remember that the vertical velocity just before it hits the ground is the negative of the initial vertical velocity. So if v subscript 0y was 20, then vy needs to be negative 20. That means we can use the a equals delta v over delta t equation to solve for our time. When you do that, we should get 4 seconds. So 4 seconds on both sides of my table. Now I can figure out what x is. Again, remember the velocity is constant. And so we just multiply the velocity by the time and get about 147 meters. Part D of this question wants us to find the maximum height. So y is my question mark. Kind of bring it over the table that we just started with. Essentially copying it from the last slide, and then taking out the things that have changed. So my initial position in the vertical direction will still be 0. My initial velocity will still be 20. My acceleration will be negative 10 still. And my Vx will still be 34.64 meters per second. But all those other things are going to change. And it's important in these multi-step problems that you recognize what changes from part to part and what doesn't change from part to part. So at the maximum height, I'm looking for y, it's important that I remember that the y velocity is 0. This is one example of a situation where the time's not really important. All we're caring about how high it goes, not how far out it goes. And so I can use this equation to solve for y. And so I get delta y is negative v initial y squared over 2a. And then substituting, it should give us something like 20. Part E of this question wants us to find the height, so again y, when x is equal to 104 meters. So we may have a fence that's at 104 meters. Question is, does it go over the fence? So again, just copying my table from the previous slide. What things are going to be different, what things are going to change. So my initial conditions still are the same. My acceleration is still the same, but everything else is going to change. So now I'm told what x is, and I'm looking for y. So I'm going to find the time first. Since my question mark's on the left side, I'm going to use the right side of my table to figure out what t is. So velocity is constant velocity equation of motion. So t is x over vx. And when we plug in, we should get like 2.85 seconds. So that goes in my table. And now that I have a time, I can find y. Use the y equals y initial plus v initial yt plus 1/2 at squared equation. Be careful, your initial velocity is not 0. And remember to make your acceleration negative. Otherwise, you're going to get a completely different number. And when you do that, you get 16.4 meters, which is less than the height of the fence that they threw up there. And so your answer to that question will be no, it doesn't go over the fence. Your justification of that will include something about the position of the ball being 16.4 meters and less than the height of the fence. Hopefully this review has been useful to you. As always, if there's any questions or things that you don't understand still, please let me know during class or during tutorials. Thank you.